Have you ever looked up into the night sky and wondered what's out there? It's hard not to feel a sense of awe when gazing at the Milky Way, our home galaxy. But while we may be comfortable with our corner of space, it's just a tiny slice of what's out there. In fact, our Milky Way is only one galaxy in a huge group called the Laniakea Supercluster. And all the galaxies within Laniakea are collectively flowing towards an unknown gravitational anomaly known as the Great Attractor. Here's what we know about the mysterious force drawing in our galactic home. It all starts with the Milky Way. Our galaxy is around 100,000 light years across and contains around 100 billion stars. While it's massive, it's just one of many galaxies in the universe. In fact, our galaxy is part of a local group containing around 50 galaxies that are all gravitationally bound together. But even this group is just a small piece of the cosmic pie. The Milky Way is also part of a supercluster of galaxies known as Laniakea, which is 520 million light years across and contains around 100,000 galaxies. The name Laniakea comes from the Hawaiian word for immeasurable or boundless, fitting for its vast size. All the galaxies in Laniakea, including the Milky Way, are moving toward the center of the supercluster. This isn't surprising, as the gravitational pull of all those galaxies would naturally draw matter toward the center unless something weird was going on. But researchers noticed something odd about our galaxy's path. In 2014, scientists used data collected by NASA's now retired Spitze Space Telescope to track the speed of stars in the Sagittarius, a small dwarf galaxy near the Milky Way. They found that these stars were moving unusually fast and in a strange direction. Upon further investigation, they realized that the Milky Way wasn't traveling in a straight line like most other galaxies in Laniakea, but was instead on a collision course with the supercluster center. To make matters even weirder, astronomers have estimated that we're already halfway to the center. If the Milky Way continues on this trajectory, we'll reach the center of Laniakea in about 6 billion years. There we'll merge with the galaxies at the core, including the massive NGC 4038 and NGC 4039, also known as the antennae galaxies due to their peculiar shape. While this may sound alarming, there's no need to worry. Even though our galaxy will eventually merge with other galaxies, the chances of our solar system getting destroyed in the process are incredibly low. That is because the region where the Milky Way will merge with the antennae galaxies is really just a thin plane compared to the immense volume of space. Our Sun would simply find itself orbiting a new center of mass after the merger, much like it does now, except the star closest to us would no longer be Alpha Centauri, but a new galactic neighbor. As astronomers continue to study the Great Attractor, they've found more oddities. For example, not all galaxies in Laniakea seem to be headed to the same place. Some smaller galaxies appear to be on a collision course with the Milky Way, such as the Sagittarius and Canis major dwarf galaxies. Others appear to be orbiting the supercluster like the large spiral galaxy NGC 6753. Meanwhile, some galaxies outside Laniakea seem to be drawn toward the Great Attractor, such as the Centaurus, a cannibal galaxy located in the neighboring Norma cluster. This suggests that the Great Attractor's influence extends far beyond the boundaries of Laniakea, possibly affecting structures on the scale of hundreds of millions to billions of light years. To understand how so many galaxies can be affected by one gravitational anomaly, let's take a look at the nature of the Great Attractor itself. Astronomers know that the Great Attractor exists because of its effect on nearby galaxies. They don't know exactly what it is, but they do know that there is something massive at the center of Laniakea pulling in all these galaxies. The question is, what could be so massive? One possibility is that the Great Attractor is made of dark matter, an invisible substance that makes up a quarter of the mass in the universe, but has never been observed directly. Dark matter is thought to exist because of its gravitational pull, which affects how galaxies rotate and how clusters of galaxies move. If the Great Attractor is made of dark matter, it would make sense why it's so massive yet invisible. However, scientists can't be sure if that's the case until they detect dark matter directly or image the center of Laniakea, which is very challenging since it's so far away. Another possibility is that the Great Attractor is made of normal matter, such as stars, gas, and dust, but that it's hidden from view. One theory is that the Great Attractor is a massive black hole, an object so dense that not even light can escape its gravitational pull. Black holes are known to warp spacetime and can pull in matter from billions of light years away. In fact, scientists believe that every large galaxy has a supermassive black hole at its center. So it's possible that the Great Attractor is a giant black hole at the center of Laniakea. However, if that were the case, we would have probably seen it by now. That's because black holes can be detected by observing the effects they have on nearby objects, such as stars and gas. We haven't seen any evidence of these effects near the center of Laniakea, which makes it unlikely that the Great Attractor is a black hole. Another possibility is that the Great Attractor is a massive structure made of normal matter, such as a giant galaxy cluster or a group of galaxy clusters. Scientists have actually ruled out this theory because if the Great Attractor were made of normal matter, we would have seen it by now. That's because normal matter is visible and there's no large structure in the center of Laniakea that we haven't noticed. This leaves us with the most intriguing possibility that the Great Attractor is a huge dark matter halo. If this were the case, it would be the first time scientists had directly observed dark matter. In fact, it would revolutionize our understanding of the universe because it would provide direct evidence for the existence of dark matter. Unfortunately, we won't be able to confirm this theory until we can image the center of Laniakea and detect any dark matter. This is currently beyond our technological capabilities, but it's only a matter of time before we make this discovery. As we learn more about the Great Attractor, it helps us better map our position in the cosmic web, the vast network of galaxies and galaxy clusters that stretches throughout the universe. Once we understand where we are in the cosmic web, we can start to piece together how our universe began and evolved over time. We can also use this knowledge to predict the behavior of galaxies in the future, including the Milky Way. By studying the motion of galaxies in Laniakea, scientists can learn more about the distribution of dark matter in the universe. They can also use this knowledge to develop new theories about how galaxies form and evolve. So, while the Great Attractor may be a mystery, it's one that scientists are eager to solve. By unraveling the secrets of this massive gravitational anomaly, we can gain a deeper understanding of our place in the universe. And who knows what other discoveries we might make along the way. So keep looking up at the stars and keep asking questions. The universe is full of wonders and we're just beginning to explore it. In the meantime, we'll keep searching for answers to the great mysteries of the cosmos. From the smallest particles to the largest structures, we're uncovering the secrets of the universe one by one. And who knows what other wonders we might find. So keep looking up at the night sky and keep wondering. The more we explore, the more we discover, and the more we learn, the more we realize how much we don't know. But that's what makes the pursuit of knowledge so exciting. There's always something new to discover, something new to learn, and something new to wonder about. Thanks for watching this video. If you enjoyed it, please leave a like and subscribe for more.